Hi, this is Pat Kelly. Okay, in this problem, they've given us an f of x and a g of x, and they ask us to find each of these expressions. And for that last part, they also say to find the domain of that. With that in mind, let me actually start with something pretty quickly, I hope, is f of x and g of x. I'd like to know what each of those domains are. So the domain of f, you can see that the only bad thing would be x equaling a -1. So the domain is x not equal to -1. And with g of x, it's actually even friendlier, right? Because there's no problem. All reals. Okay, done. Now let's move on. We'll use that information later. For each of these, what we're doing is that arithmetic combination of functions. So in this case, f plus g of x. Start with this if it helps, realizing what that actually means. It's just f of x plus g of x. That's our definition of that notation. So that means the work I want to do is this equals, and I just grab f of x, which is up here, plus g of x, plus x cubed. That's really it in terms of putting them together. Now you might want to simplify, and I think I probably would get a common denominator here, make it one fraction. That might depend on the context of the problem if you're working with this expression further, if you might have to do some work with it. But it's not too bad. Common denominator would be that x plus 1. So this second term, I'd end up multiplying by that common denominator. And I'd get that, x to the 4th plus x cubed. I'd still have this numerator plus x, all divided by that common denominator of x plus 1. Okay? Done. Moving on. Part B is f minus g of x. And very similarly, if it helps, start with what that means, which is exactly what you hopefully think it means, f of x minus g of x. So my algebra here will be to grab exactly what we did before, the f of x, x over x plus 1, and then subtract g of x, which is our x cubed. I'd kind of like to get a common denominator again. It's that same denominator of x plus 1. I do want to keep an eye on that minus sign, though. So this would actually be a minus x to the 4th minus x cubed. This would still be a positive x, still divided by x plus 1 for the denominator. Okay, done with part B. Part C. Now we're looking at fg of x, so f times g. And if it helps, again, to start, you can write down what this actually means, which is f of x times g of x. So my work, very much like before, is going to be to grab the entire f of x function, x over x plus 1, and I'm going to multiply this time. For safety's sake, I might put parentheses around my function expressions. Multiply that by g of x, which is x cubed, and then simplify where appropriate. I can clean this up a little bit. If I push that x cubed up top, x to the 4th over x plus 1. And I can't simplify that any further. So in fact, I'm done. Part D is the division. And if you haven't been studying at all and you're just kind of picking this up right now, I bet you can even guess what this next step is. It's f of x divided by g of x. My point is, same pattern as all the other algebra, right? This one's just division. So you grab the entire f of x function and put that in the numerator. X over x plus 1. Again, if it helps, maybe parentheses. Now I'm doing division. I want to make sure I see what's being divided by what. G of x is my x cubed. And I'll pause for a second because it is important with this fourth arithmetic combination of division. It's important at this step that you realize, hey, wait a minute, g of x, that's a denominator right now. That can't be 0. we can never have 0 in a denominator, right? So I do want to make a note over here that x cannot equal 0. Now the official word is that g of x, the whole thing, cannot equal 0. And so that'll depend what your g of x function is. What you want to be thinking of is what value of x makes this 0. So see, I got an easy one in terms of, well, x equals 0 would give me x cubed of 0. But whatever this expression is, don't let it as a whole equal 0. And make that exception right here then, whatever x value would make g of x 0. Okay, then let's continue, which is, as usual, simplify, clean up a little bit, right? So I'm going to rewrite x cubed as x cubed over 1, just so that I can see my flip and multiply, invert and multiply, however you learn to phrase that. If I flip and multiply, that 1 comes up top and multiplies by the x. The x cubed goes downstairs. And I'm still looking at the x plus 1 downstairs. And then I can see some more simplification with x and x cubed. I'm just going to get a 1 up top and x squared in the bottom times that x plus 1. All right, you're almost done, but they did want us to find the domain of this fourth one. And the domain needs to be from the originals, which is back to these domains I found to begin with. We're looking for the overlap of those. We need values of x that belong to both guys. And there was only one exception. That was that f of x couldn't let x equal a negative 1. But also, we threw in this exception of x not equaling 0. So my domain for this problem, stick with orange, my domain would be x not equaling that negative 1, but also x not equaling 0. Let me try to summarize that real quickly again, is the x not equal negative 1 came from the domain of f. You have to exclude everything that would be excluded from either f or g's domain, but I also have to throw in that x not equal to 0 from this division concern of mine. Okay? All right, decent amount of work, but still good work, good practice. So go do some on your own.